Hello and welcome to UNCC Glass under the mentorship of Dr. Tao Han, Pedro Regalado Vera, and Professor Busaba. Objective. The goal of this project is to create a network mixed reality system for real-time object detection and localization. The system will utilize a Microsoft HoloLens and a cloud server to perform object detection on any given environment in real time. It will tell the user the name of the object and put virtual markers on the real object in the environment. Background. Mixed reality is an exponentially growing field, and the Microsoft HoloLens is one of the most widely used mixed reality headsets in our project. In our project, we use the HoloLens 1 to project 3D images or holograms into the scene to aid the user.
System overview. The system consists of the Microsoft HoloLens, responsible for mapping the environment and labeling objects, and the cloud server, responsible for object detection and parsing image data. They will exchange data via socket connection. The video feed from the HoloLens is sent across the socket where an image recognition algorithm called YOLO version 5 identifies objects and echoes their names in 2D coordinates back through the socket. Meanwhile, the HoloLens will create a 3D map of the environment and raycast the environment mesh using provided coordinates to create a marker in the scene. Here's an image of what the markers look like in the scene.
System specifications. The specifications for our system are 1. Have an object recognition algorithm capable of detecting multiple objects. 2. Have a localization and mapping algorithm that locates and maps both the user and environment. 3. Have an easy-to-use user interface for the object detection. 4. Have a control algorithm capable of altering speed and quality. And 5. Have a system capable of detecting objects and labeling them within 3D space.
Communication and networking. Communication and networking consist of a client socket and a server socket to send data between our HoloLens and server. Using an asynchronous UDP socket, it will receive an image stream and from the HoloLens, and the server will return processed data including the object name and location.
Capturing and rendering. Capturing and rendering collects image data through the HoloLens camera to send to the server. The design uses a user interface to toggle object detection. Once the processed information comes back from the server, the HoloLens will raycast to the collider of the object to collect spatial data and create correctly localized object markers in the scene that can be toggled between renders of markers and bounding boxes.
Data processing. Our data processing design consists of the socket server, our object detection algorithm YOLO version 5, and OpenCV. Using YOLO v5 algorithm for object detection and OpenCV for image parsing to identify the center of the object in the 2D image. The coordinates of the center will be found as pixel values, which will then be projected proportionally to raycast to a location in the 3D scene once on the HoloLens.
In conclusion, the prototype of the project was created successfully. Overall, our team UNCC Glass was able to complete the specified requirements to return a working model that got mentor approval. Thank you all for listening.